Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram. So welcome to online video lecture series. In this lecture, we will be discussing about the relation between the convolution and the correlation. In this lecture, we will discuss about the relation between correlation, convolution. Two important operations on signals and system. X1 of t and X2 of t are the input signals, or two signals. Then you can calculate the convolution x of t equal to x1 of t with respect to x2 of t. Because convolution is commutative, this is x2 of t convolution with x1 of t. So simplify this is integral minus infinity to plus infinity x1 of tau x2 of t minus tau theta. T minus tau theta. And similarly, this is minus infinity plus infinity x2 of tau x1 of t minus tau theta. So coming to the correlation R2 of tau is equal to integral minus infinity to plus infinity x1 of t x2 of t plus tau dt. Another equation minus infinity to plus infinity x1 of t minus tau x2 of t dt. So by comparing these two equations, x of t equation and R12 of tau equation, so we can get, so simply by interchanging, so suppose this is considered x1 of tau and x2 of t minus tau beta. So similarly, x1 of t, we are differentiating with respect to t. By comparing these two terms, so here this is minus t and here is plus t. If we change x1 of t convolution with x2 of minus t, then we will get the corresponding equation for this. So let me take one example for understanding the convolution. 0, minus 1 and 1, its value 1. So treating this as x1 of t. Similarly, x2 of t is another rectangular function. Height would be equal to 1 by, this is 1 and this is minus 1. Height will be 1 by 2. So using convolution, if you want to calculate x of t equal to integral minus infinity to plus infinity x of tau, that is x1 of tau and x2 of t minus tau theta. Or we can say minus infinity plus infinity x2 of tau x1 of t minus tau theta. Depends upon our convenience, we can keep one signal constant. Second signal you have to take the mirror image. So steps involved in convolution is, first one is you have to take folding, second one is shifting, then is multiplication, fourth one is addition. And first we will try to draw this. So for my convenience, I am keeping this is constant. This is x1 of tau, value is 1. So similarly, x2 of tau is also having the same 1 minus 1. This is x2 of tau. It will be 1 by 2. So when you take x2 of minus tau, because this is a symmetric, because this is a symmetric about origin and even function, this will have the same coordinates. So this is x2 of t minus tau for t equal to 0. That means this is x2 of minus tau. So as long as t value, is less than minus 1, so as long as t is less than minus 2, there will not be any overlap. There is no overlap. So that means if you draw, this is somewhere here, this is somewhere here, this is less than minus t. So there is no overlap. Overlap portion starts at t equal to minus 2 and t equal to minus 2 to overlap portion. So it will go up to 0. So portion output will be linearly increasing. So this is the standard. This is 1 and this is minus 1. Overlap portion keep on increasing by selecting this value. This is t. At one point, these two will overlap exactly. These two will overlap exactly at t equal to 0. That is, there is a complete overlap between these two. And this is overlap in between minus 2 to 0, and this is at t equal to 0. And from t equal to 0, t equal to 0 to 2, the overlap portion slowly decreasing. And this is the original. Yeah, this is t. The overlap portion slowly decreasing. So here you need to understand this with a less amplitude, because we have considered amplitude of this will be less than this. Similarly here, less than this. Okay, now this is overlap portion. At t equal to plus 2, the overlap portion stops. So finally what you will get is output will be like from, it will start from minus 2, the area will slowly increasing, and there is a maximum value at t equal to 0 and slowly decreasing till 2. This is minus 2, this is plus 2, and its value is 1, 1 by 2. So this is your x of t. Whenever you convolve two rectangular functions, you will get a triangular function. Same way, if you want to calculate autocorrelation, this is x1 of t and x2 of minus t. Because we are discussing with the even signals, both x1 of t and x2 of t are even functions, so there will not be any problem. So this is 1 minus 1, this is x of tau. So the second signal will be 1 minus 1, and this is x1 and this is x2, this is x2 of tau. When you take reverse also, because this value will not change, you will find, so this is a function, fixed function between 1 and next it will come here, it will come here, so there is no overlap portion, no overlap portion, so here something like this is t. The overlap portion keep on increasing, next overlap portion this is keep on increasing, and this will come here, this will come here, this is equal to minus 2, and next value will be somewhere here, and this will be somewhere here. The function slowly increasing, this is t, this is in between minus 2 to 0. So at t equal to 0, at t equal to 0, there is a complete overlap portion, complete overlap portion. This is at t equal to 0. Okay. Next, and from t value in between 0 to 2, this is 0, 1, and minus 1. This value will slowly decrease. This is t. So here this t value, this is our portion. T value will be 0 to 2. Okay, at t is equal to this value. If t is equal to greater than t, so there will not be any problem. This is t is greater than 2, there will not be any problem. So the resultant will be, output will be from starting from minus 2 onwards, the linearly area increases because overlap portion increases from 0 to, it is decreasing. So height will be 1 by 2. This is your x of t, or R12 of the autocorrelation. You can observe here one of the property of autocorrelation. Autocorrelation function will have maximum value. Autocorrelation function will have maximum value at tau equal to 0 for all other values of tau. This is for all other values of tau.